Hey guys, so in this video we're going to talk about recursive formulas for sequence. So basically a recursive formula is a formula where you need you plug in the previous term to find the next term. So if I'm looking for the whatever term I'm looking for, right? So say I'm looking for the third term, then I have to plug in the second term here. That's what n minus 1 means. It means it's the previous term from whatever term you're looking for. So if I'm, again, if I'm looking for, say, like the fifth term, if this is A5, then I have to plug in A4 here. So I have to know what A4 is in order to do this. So that's the one drawback of a recursive formula over an explicit formula is I can't just go find like the 1000th term because I'd have to know the 999th term first. So I have to know all the previous terms to find the next term, which kind of limits my uses for a recursive formula. It's great if I need to know like a string of numbers, right? But it's not great if I just need to know one term in my sequence and it's like further along in the sequence. If I need to know like the third term or something, it's probably fine. But if I wanted like the 20th term, I'd probably go ahead and write an explicit formula, not a recursive one. Anyway, so also with recursive formulas, we always need to state one of the terms. It's usually the first term, doesn't have to be. But you always need a term because you have to have a term to find the next term. So I can't just give you this and not tell you what one of the terms is, because then I won't be able to use this formula. This formula is useless if I don't have a term to work with. All right, so if I'm given this formula and I want to find the second term, I plug in the first term here, so I'd plug in 3, and that would give me the second term. And then if I wanted to find the third term, I would plug in 5, right? If I want to find the fourth term, I plug in 9, and then I would plug in 17 to find the fifth term, and so on. Yeah. Some formulas, like the one for the Fibonacci sequence, use 2 previous terms, because remember, we get the Fibonacci sequence by adding the 2 previous terms together. That's how that works. And so I need to know both the first and the second terms before I can start. And then this formula is saying if I want, say, the third term, I need to take the second term plus the first term. So the previous term and the one before that, and add them together. So then I would get 2, right? 1 plus 1 is 2. So then for the third term, I would take for the fourth term, I would take the third term plus the second term. So 2 plus 1, which is 3, right? And I would keep doing that. So that's how that works. All right. So basically, we already talked about this. You're just plugging in the previous term each time. We can graph these as well. Same deal. Sorry, I'm looking for what I actually want to talk about. Writing a recursive formula is what I'm looking for. I am going to talk about factorials, but I wanted to talk about writing a recursive formula first. But there doesn't seem to be an example for that. Okay, so writing a recursive formula, you're basically, instead of you're still looking at what's changing, but instead of looking at, so in explicit formulas, we're looking at things like, okay, this number is 2 to the first, this number is 2 to the second, this number is 2 to the third. Instead of doing that, for a recursive formula, you're going to say the numbers are being multiplied by 2 each time. So if we went all the way back to the beginning of the chapter and looked at that sequence, we would see that the numbers were being multiplied by 2 each time. For explicit formulas, we said, okay, those are power of 2, so my explicit formula is 2 to the n. My recursive formula would be 2 times a n minus 1, 2 times the previous term, because you're multiplying by 2 each time. So when you're looking for a recursive formula, the difference is that instead of just looking for what's changing, you're looking for what is happening from the previous term. So am I multiplying each time? Am I adding each time? Which you're kind of doing with explicit formulas, but you're doing it in sort of a different way. So with recursive formulas, again, you're like, okay, what is being done to the previous number to get me to the current number? Hopefully that makes sense, because I don't have an example for it. But anyway, let's talk about factorials. So factorial, this is the notation for a factorial. You use an exclamation point. And it means take that number and multiply it by all of the preceding numbers. So 4 factorial is 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. So it's that number times all of the preceding numbers down to 1. Obviously not 0, because that would just cancel the whole thing out. So you could have a formula with this. If you had n plus 1 factorial and you wanted to find the sixth term, that'd be 6 plus 1 factorial, which is 7 factorial. And then you would do 7 times 6 times 5 times 4 times 3 times 2 times 1. Also, we can split up factorials. So we can say, okay, 5 factorial is the same as 5 times 4 factorial, right? Because that would be 5 times 4 times 3 times 2 times 1. And this would be 5 times 4 times 3 times 2 times 1, right? So I can split up factorials. And this can be useful if we want to cancel things with factorials. For example, if I have n plus 1 factorial over 3 factorial. For example, say I had something like this. And so my n turned out to be 5. Okay, so I'm doing 5 plus 1 factorial over 3 factorial. That would be 6 factorial over 3 factorial. Well, 6 factorial is 6 times 5 times 4 times 3 factorial over 3 factorial. 3 factorials cancel, so this would just be 6 times 5 times 4. So you can cancel factorials, right? Because they're equal, right? So you can split, if you have a bigger factorial divided by, if you have division happening, right? And you have a bigger factorial, you can split it up and then cancel out the smaller factorial. Hopefully that makes sense. I'm going to move on. All right. Okay. Oh yeah, so 0 factorial is 1. It's just defined that way. It is what it is. The rest of these are straightforward. But yeah, that's the one where it's like, why is 0 factorial 1? Who knows? It just is. Okay, so yeah. So say you have this formula and you want to write the terms just like we did in all of the other examples. You're just going to plug in whatever term number in for n, so in both places. So this would be 1. If you're looking for the first term, you're plugging in 1, so that's 5 over 1 plus 2 factorial, which is 5 over 3 factorial. You break that down into multiplication and simplify. And so that's basically what you're going to be doing for all of these. You're just plugging in the number and then simplifying at the end. So that's how we use factorials. Pretty straightforward, hopefully. Let me know if you have any questions. And yeah, I will see you guys in the next video.